Graph the following polar curves and find their points of intersection. So we've got two curves here, which are graphed over in this corner. So we can see that they intersect at two places, and the way these are intersecting, we actually, if we kind of think about it for a second, we might be able to guess at the angle for this point up here because of the way it's positioned. But we're going to go and go through kind of the math of it. So we need to set them equal to each other. 2 sine theta equals 2 cosine theta. And at this point you may get stuck because you may say, well, I have different trig functions. Generally, when we're solving these kind of equations, we try to get them to be the same one, but they're not squared, so that makes that difficult. But I'd like to propose this as a way of doing it. We can divide by 2 on both sides and get rid of those coefficients to show basically they don't really matter. So what we need to figure out is at what angles are sine and cosine the same? Well, if I think about it, or if I look at my unit circle, the values where sine and cosine are the same for theta are at pi over 4 and 5 pi over 4. Because that's where I have positive square root of 2 over 2 comma positive square root of 2 over 2, as well as negative square root of 2 over 2 comma negative square root of 2 over 2. That's the only two places that will ever have the same value for sine and cosine between 0 and 2 pi. So that means that our angles for this are pi over 4 and 5 pi over 4. Now, to figure out what the r values for those points are, we have to take the angle and plug it back into one of these two equations, just like when we're solving a system of xy equations. We solve for one and then we have to plug it back in to find the other. So I'm going to have to take pi over 4 and I need to plug it into either one of these, and no matter which one I plug it into, I should get the same thing. So I'll just pick the first one. R equals 2 sine of pi over 4. Now you might reach for your calculator at this point, but that would be silly because we know that sine of pi over 4, either by memory or by drawing a triangle or by looking at our unit circle, we know that sine of pi over 4 is square root of 2 over 2. And so r equals 2 times square root of 2 over 2. So that's like 2 over 1. Our 2's cancel, so r is really just square root of 2. So that's the r value that goes with pi over 4. In a similar way, we can figure out what goes with 5 pi over 4. I can plug 5 pi over 4 in instead, and I can do it with sine or cosine, like either of these equations, I mean. It doesn't matter which one. Now, with 5 pi over 4, I'm going to get a negative square root of 2 over 2, which I times by 2, which gives me negative square root of 2. Now, let's think about these two answers we got. Pi over 4 is an angle right here, and square root of 2 is about 1.4, which if we had this graphed in on like a polar scale where it has the circles or whatever, that would probably be where this is. So this looks like square root of 2 comma pi over 4. Now let's think about 5 pi over 4. That would be this direction, and a negative square root of 2 means I would graph the opposite direction. And so basically what's happening is these are actually giving us the exact same point, which means we don't really need both of them, we only need one. So how do I figure out what this other point is? Well, somehow these are intersecting at basically an r value of 0, but the problem is that happens at two different thetas. And so what we do to write that answer is we say that they also intersect at the pole. So the pole is basically the line that we're starting at, this line at 0. We're saying they intersect at the pole, which just means it's kind of like saying they intersect at the origin, but for polar graphs. And that is kind of a wibbly wobbly polar equation-y kind of a thing that happens, that for one thing, it's weird that we just got the same point twice, so they're not really both like we don't have to write both answers. But then it's also like our equations couldn't tell us this other intersection because the thetas, like, they aren't the same um, for those values, so it couldn't tell us from the equations. But from graphing it, we can see that one of our answers is the pole.